Okay, this is the last video for lesson 1.5, and we're going to go ahead and take a look at some percent problems. We saw one earlier in the warm-up. We dealt with the percent problem, and I'm going to show a different way to solve these type of percent problems. We're going to look at one specific type, but this equation here that I'm going to have us use, this is actually really good for solving all sorts of different types of percent problems when we're trying to maybe find the percent or find part of it or find what the original value was. And this here is set up so that whatever the percent value is, you're going to plug it in here. This is always 100. What this side does is it changes a percent into a fraction. So if I have, like in this first example, I have 20%. If I put the 20 here and I put it over 100, I have now changed the 20% into 20 per 100, so it is now a fraction. Now the other thing we're going to look at is on the right side, when you're looking at a percent, think about it as a pie, right? And we talked about fractions as a pie. And fractions, decimals, and percents, when they're expressing something that's less than the whole, less than 1, we're going to have the total value, like the total number of slices of pie, and how many pieces we have left, right? That's kind of the concept we use to describe fractions. And that's what we're doing here. So this is either going to be the total or the original value. And then this is going to be the part, right? This is going to be less than whatever that is. So, if I had 10 pieces of pie, then this is going to be something less than 10, right? If we're talking about a value smaller than 1. So in this case, we want to find 20% of 150. So 150 is like our original number. And then we want to find what's 20% of that, so a smaller portion of that 150. So we're really looking for the part. So I could use a question mark saying we don't know what this answer is, that's what we want to find. Or you could use a letter to represent the unknown, right? So in this case, we could use an X to represent that unknown instead of a question mark. And that's what I'm going to go ahead and use here. So this brings up an interesting kind of conversation in that I'm using the letter of X, and this is very common in algebra, and using this specific letter, but we also use this symbol as a multiplication symbol. So when we start introducing the variable X, the letter to represent an unknown, we're probably not going to use that little x to show multiplication anymore. We'll use a dot, we'll use parentheses, but we probably won't use an x, a symbol to represent multiplication. So in this case, x is going to be the part, right, or the 20% of 50. So what is the 20% of 150? Sorry, I said 50. Of 150. So to set this up, to solve it, all we need to do is get the x by itself. And whatever's on this side is what x is going to be equal to. So in this case, I have 150 in the denominator. So this is x divided by 150. Now, what's the opposite of division? If you said multiplication, you're correct. So multiplication and division are opposite. So if I multiply by 150 on this side, this should cancel this division of 150 since they're opposite operations. But if I multiply it here, I have to do it on the other side as well. So I'm going to multiply 150 on both sides. Please note where I put my dot, the dot always goes in between the numbers you're multiplying. So sometimes when I do this, I'll have people wanting to put the dot here. Since I put the dot in front of the 150 here, they'll try to put the dot in front over here. It always goes in between the numbers you're multiplying. So this cancels, and I'm just left with the x. So all I have to do is multiply all of this together to find the answer. So if I do 150 times the 20 divided by the 100, I get 30. And that's my answer. So 20% of 150 is 30. If I do 30 divided by 150, I do get a 0.2. And a 0.2 is a 20%. So just to confirm that this is 20% of 150. So that answer is correct. And so we can use this equation to find values. And the process we're going to use for that is to get that variable by itself. So let's go ahead and set up another one. Take a look at the next problem. So in this case, this is always 100, and the percent always goes here. A $40 shirt is on sale for 25% off. What is the discount? So for this one, I'm going to put the 25% here. This $40, that's the original price. And so the original goes in the bottom. And so we're trying to find how much the discount is, this 25%. We want to find what is 25% of this 40. So once again, I'm going to put the X here, where X is the discount. It's the discount amount, or how much money we're going to save. And just like over here, I want to get X by itself, which means I need this 40 to go away. And since it's X divided by 40, we're going to multiply by 40 to both sides. I guess I could put this dot a little higher. I thought it was weird how I was like putting it down here. So now here, the 40's canceled, just like the 150's canceled. So that's what's really nice about this. It's a really easy step to do, and then all I have to do is plug that into my calculator. So my 40 times my 25 divided by 100 is 10. So that means that the sale gives a $10 discount. So once again, the problem said it was 25% off. Well, 25% off $40 is 10. And so that's how much the discount. So you'd pay $30 for the shirt. All right, let's go to the next one. Once again, I'm going to set up the same fraction, equal fractions. This 100 goes here, and then above it is always the percent. So this is 15%, or 15 per 100. So we change this 15% into a fraction. And then this 200 is our original value. So we want to find 15% of 200. We'll put our X here. And once again, we got to get rid of this number on the bottom. So what would we multiply to both sides to make this 200 go away? A 200. So each time it's been the number in the bottom that we've multiplied by. Because multiplying by 200 cancels a division of 200. So we have X equals, and now we'll go ahead and multiply. 200 times 15, divided by 100 is 30. That winds up being our answer. And I apologize, I started working on that. That was a your turn problem, so you were supposed to do that. Go ahead and do the last one. Be careful on using information here, what you're going to find out using this equation, and then what they're actually asking you for. I apologize. That was a different problem. Just go ahead and use the same process for part B, and you should be able to get that answer. So go ahead and pause your video, work part B, and then I'll go over it. Okay, so the setup you should have, there's your 100, the 18 goes here, so 18% becomes 18 per 100. The 56 is the original bill. So we want to find how much the tip is. We want to find what part of 56 do we have to pay to do the tip. And same process, I want to get rid of 56, so I'm going to multiply both sides by 56. And that cancels. And now we have 56 times 18 divided by 100. That's going to be 10.08, or in other words, $10 I should have put the tip amount for X. A lot of times when I just put a letter, this can get confusing. It's like, what's that supposed to be? But since we know we're trying to find the tip amount is what X is. So once we find out what X is and we get a number, we know, oh, that's how much you should tip on a $56 bill. All right, let's flip to the last page. All right, these problems here are just practice problems. So go ahead and work all 8 problems. Pause the video, work the 8, and then unpause. Or if you want, you could work a problem, watch the answer, then pause, work a problem, then check the answer. And that's usually a pretty good model to do. This way you're getting feedback as you go. Be careful with number 8. Read it carefully for what they're asking you to find. All right, so go ahead and I will go over the answers here in just a second. All right, so for this problem here, I'm going to go ahead and do these by hand, but calculator is what I'm going to be assessing you on. But I still think it's good to practice doing this by hand. So for this one, I just lined up my decimals because I'm doing addition. 0 plus 2 is 2. 8 and 7 is 15. So I have my 5 and the 1 carries over. 6 and 5 is 11 plus 1 more is 12. Carry the 1. And 4, 1, and 1, that is 6. So we have 6252. That should be our answer. Over here, we're going to do subtraction. So we have the 90.3, and we have to line up our decimals. So the 48.65 goes here, and we're subtracting. Now on this, we're going to have to borrow. There's just no way around it. I can't subtract 5 from nothing. So this 3 becomes a 2, and that allows me to bring a 10 over. And now I can subtract. 10 minus 5 is 5. This is too small, right? So I can't subtract this unless I borrow. But there's a 0 here. There's nothing to borrow from. So I got to go over 1 more. And this 9 becomes an 8. That then allows me to bring a 10 over. The 10 becomes a 9, which allows me to bring a 1 over. And now I can do 12 minus 6, which is 6, 9 minus 8, which is 1, and 8 minus 4, which is 4. So 4165 is the answer on that one. For this one here, I'm going to go ahead and do that box. We'll put the 75 up here and the 32 there. And then we'll just multiply through each box. 5 times 3 is 15. 5 times 2 is 10. 7 times 3 is 21. And 7 times 2 is 14. So we just multiplied to get all the values in the box, and now we'll add. That's just a 0. 5, 6 plus 4, that's 10. So I'm going to have to bring a 1 over into this diagonal. Now there's a total of 4 and a 2. So it's 2400. Since there are 2 decimals, 2 numbers after each decimal, total of 2, we're going to put the decimal with 2 numbers behind it. So the answer here is just 24 if we simplify that. And then for this one here, this is going to be division. Remember, we can move these decimals over, so we're really dividing by 9 into 126. And we'll go ahead and do that process, but by moving those decimals, we don't have decimals anymore. 9 only goes into 12 once, and if I subtract, I get a 3. And 9 goes into 36 4 times. 4 times 9 is 36. So this does divide evenly, and 14 is your answer. All right, for your next two, this is just converting this percent to a decimal. We just move the decimal twice. So if the decimal's here, we move it over, so it's now in front of the 6. So 0.62 is your answer. To convert this to a percent, we move it the other way, so that becomes 38.5%. You can also multiply it by 100 to get that result. And on this one, if you divide 62 by 100 on your calculator, you get that. All right, last two. So this one I am going to set up this this equation, and the 12% goes up here, so it's now 12 per 100. It's changed to a fraction. The 250 is the bottom, so we'll put it there. It is the original value, and we're trying to find the part of the 250 that would represent 12% of 250. And just like the other ones, to get rid of this bottom number, you just multiply by it to both sides. So 250 gets multiplied to both sides, and it cancels here, and we're just left with x. Over here, then we do our 250 times, 250 times 12, nope, try that again, 250 times 12 divided by 100. 250 times 12 divided by 100, 30. So 12% of 250 is 30. And let's do the last one. Now this one we have to be a little more careful with. So a pair of shoes, it's $120 for the shoes, and it's marked up by 15%. Now marked up means the price is actually going to increase. But I still need to find what is 15% of 120 to find this answer. So here's 15. 15% becomes 15 per 100. This is the original price, so it goes on the bottom. And the X is going to be the markup amount, how much they increase the price. So just like the other ones, to clear, to clear the fraction, to get rid of this number on the bottom, we multiply both sides by 120. That cancels, and now we just do the multiplication on a calculator. 120 times 15 divided by the 100, 18. So what does that tell us? That is the markup. So the price is going to increase by $18. Now we go to the question, what is the final price? Well, if it was 120 and they did a markup of $18, I'm going to have to do the 120 plus the 18 to find out that the new price is $138. Alrighty, and that is the end of 1.5.